Hey, hello there. How are you? Hope you are good. So, let's start an exercise. This exercise is for detecting the water using Copernicus SAR GRD data. You can read all about this data here. This is the Sentinel-1 and it's using C-band, and here we will use the GRD scenes. So, and this is the polarization. We will be interested in VV and VH. And why we are using to detect the water. You know, water is very important component of environment. It's a life. But when this is in excess, unwanted, then it becomes the cause of death and is in the form of flood. So it's very important to know that the flood affected area. So using this data we can do this work easily and very accurately. As you know that this data is belongs to radar data, and this data has no effect of the cloud cover. So it's very significant to use this data to detect the flood area. So the data which I'm using to detect the flood is here, the code which I'm using, and this is the exercise third. And in this exercise, as I have told you that we are using Sentinel-1 synthetic aperture radar data to delineate the open water surface along a segment of Niger River in Nigeria. So this is my area of interest. You can change as per your need, and this coordinates belongs to this area here. This area belongs to this area. Okay. And now then we move to image collection construction. This part from 6 to 14. We are constructing image construction here, and we are using the image collection, image collection. So this is the class construction here. This is the class construction, and the in red color, this is what we say is the method. So as you will run this code, you will get that how many images are there in this period of time, which is from August to October. So this is the time of heavy rainfall, and you know what is the concept is why this data is very important for water. The reason is the water surface is smooth. So at the smooth surface, when this energy interact with the water, because the smooth surface is smooth, then it will not bounce back to the detector. It will scatter here and there, and then the values will be very low at the surface of the earth. At the surface of the water. On the other hand, if the surface is rugged like vegetation, then the energy will be bounced back more to the detector, and the detector will detect more energy from the rugged surface like vegetation. So vegetation as well as water. For these two components, this radar energy is very useful to detect the water, to detect the vegetation, and we can use this energy in agriculture, uh, agriculture or crop growth or crop detection, especially the paddy cultivation. When we are growing the rice, then there is an combination of water, and then the water you have to use the water full of your field should be full of water. Then this energy is also useful for that task. So now I'm coming back to the topic. The topic is how we can detect the water using this Sentinel data. And here code number 6 to 15, I have already construct the image collection here, and we have applied the server side method, chained server side method. What are the method? That this is the filter bound here, this is the filter date, this is the instrument mode we need is IW, of course. Then we need VV and VH because this polarization will give you better data. We are selecting here VV and VH, and thereafter we are printing, and we will see that how many images belongs to. Then we will run it, and then we will get it here, print. So how many? 5. After filter, how many? 5 are coming. Okay, then we'll get its median of 5. So we will have a single image, and that single image, as I said to you, when the energy interact with the water, most of the energy is lost here and there and does not go to the detector. That's why the values are very low. So I need the values which are less than -17. I will run the code and you see the result. So as I told you, the values will be very low. Here this is the data. So dark area shows the lower values, and higher value shows that where the more energy is bounced back to the detector. So as you can see here, this is the town here, and from the town there are the structure, buildings. So the surface is rugged, and because of this rugged surface, more energy is bounced back to the detector. That's why the values are high, and this is white. On the other hand, if you see the water area, because the surface is smooth, here most of the energy is lost here and there. That's why here values are very low. And as per the condition, you see that this is the water. You can notice how accurate is this. It has a very high level of accuracy. So if you are doing your work, if you are doing your research work, and your objective is to detect the flood area or damage caused by the flood, you can use this data, and thereafter you can take this mask out and you can do analysis using ArcGIS or QGIS. It will give you a good results. Then you can go for accuracy assessment, and then this accuracy assessment will be very, the result validation, it will be higher. So let me go Further to another very important point, if your study area is bias state, then you go to bias state. Bias state belongs to around 4 degree latitude here, and then you run it. The same time period, and this is 2022 and 2022 here. Bias state is full of water and vegetation. So you can see the vegetation area is giving you moderate energy, but on the other hand, the settlement is by high values, bright color. I mean, so values are more there, but the water area, the values are less. That's why you can detect the water very well here. This is a very unique region, very unique region. You will not, maybe you will find the similar characteristics there in West Bengal or Bangladesh, where the Indo-Gangetic, sorry, the delta is there, made by Brahmaputra and Ganga, and this is the Niger delta. This is Word Film delta, and this is a very unique ecosystem. So this is all about how we can use the Sentinel data, Sentinel-1, to detect water and vegetation or even the settlement areas. So this is all about this video. In the next video we will talk about the NDVI. If you like this video, you please subscribe my channel. It will motivate me, and I will make more videos for you. And you can comment me that what another videos you need for your study, your specific study. I wish you all the best. Have a nice day. Thank you so much. Bye bye.